All right, how's it going, everybody? Today we are going to be working on a review of section 8.1 through 8.5. Now, it's going to be a little bit of a mix of everything, but this is going to start preparing you for your Unit 8 test, which is coming up shortly. So we need to start getting ready for it now. Now, we've done this before. We are going to be doing the We Do problems together here on the video. Your classwork is not just the We Do that you're going to copy as we go along. Remember, your classwork is anything in the You Do column. So, yes, you need to work these problems out, but you're going to see how to do them anyways. And then you're going to turn this in before you leave for embedded support, as well as the homework, because there's very little work for today. All right, so here we go. Let's look at that first problem. Now, very first one says circle A can be mapped onto circle A prime by a translation. All right, that's easy enough. We've done translation before. We've seen that in our word wall. In a translation, it says describe the translation of circle A. Well, just remember, when you do a translation, you start by saying XY is going to be moved. You're going to let someone know that we're going to be moving this circle to a new location. But we do have to remember which one is the original circle, the pre-image, and which one is the new circle, the image. So this one right here, look at that, is the original. How do I know? Because it doesn't have a prime symbol on it. And we're going to move it here to this new one. Now notice that I've only highlighted the center. When we did transformations or translations in the past, we always cared about one point. Well, let's use the center because that's the easiest. So when we're setting this up, yes, I'm going to write another point X, another point Y, but notice how we left a little bit of a gap. We are going to start looking at how do I go from this point to this one. Now, you can count in any direction. Now, for many of you, I know you'll probably do this first. You'll say, hey, I'm going to go 1, 2, I got to go 3 spaces up. But what you needed to remember is this. That doesn't mean you put a 3 here with the X. Moving up and down affects the Y axis or our Y values. So if you go 3 up, then that 3 should be over here. And because you went up, then that's why we say plus 3. But they're asking, well, how did I get from here to here? All right, so we're not done yet. I also need to move, let's see, 1, 2, 3, 4, 5 spaces to the left. So we go 5 left. And that's all we really have to do is just keep count. But because I'm moving to the left, remember, moving left and right, just like the x-axis, that means the number 5 belongs with the x. But because I went to the left, it should be a minus sign. We moved to the left. So again, that should be a -5 for this problem. And just like that, that's it. You have a question just like it on your test. You have one here on the side to practice, but we'll get to that shortly. So I'll give you a moment to catch up with the writing. All you have to do is count spaces very carefully, but you have to know who the original point is and who the new one is off to the side. So let's try question number 2. Again, this is a little bit of everything that you see on the test for Unit 8. Now, this is one of the newest things that we learned. Now, a lot of you were absent on the day of this lesson, but let me just show you how it works. This right here is the equation of a circle. When you have an equation of a circle, you're always going to have that plus sign in the middle. They're always going to have powers of 2 here. And then these are the things I look at. Yes, there's a value that has an x. Yes, there's a value that's connected to the y. And then this number over here is its own special number. So here's our breakdown from what we learned just this week. One of the things that I need in order for me to draw a circle like I have it here, I need a center. Without a center, you can't really draw a circle anywhere. So I'm going to go here. And when I'm looking for my center, we have to keep in mind, the center is basically an x and a y. So for this problem, my center is, well, let's see. It says x plus 3. But what we mentioned in class is that doesn't mean I'm going to put a positive 3. I'm going to put a -3. We have to think opposite. If you were in Algebra 1, we would have, for this problem, right here, the one that says x plus 3, we would have made x plus 3 equal to 0. And then look, we take away a 3. That's why we say always think opposite of what's there. And if that's the case, if it says y minus 2, well, I need a y value. But because it's a minus 2, we'd go with positive 2. So there's my center. When I have my center, negative 3, 2, I'm going to draw it. Back 3, down 2, there's my center. Now, I'm not ready to draw a circle yet because I do need one more piece of information for this problem. And that piece of information that I need is the radius. And in order for me to find the radius, that's where that number 16 comes into play. So as I'm looking at my 16, that is not my radius. I definitely don't want to count 16 spaces away every single time. So for my radius, all I have to do is take the square root of 16. You take the square root of whatever number's there, whether it works out nicely or not. And the square root of 16 is 4, and that's our radius. Now, what that means for us is this. When I know that my radius is 4, so I've already pulled all the info I need, that means I'm going to count 1, 2, 3, 4 spaces this way, right, to the right. But I also need to go 1, 2, 3, 4 down, 1, 2, 3, 4 to the left, and 1, 2, 3, 4 heading up. And now that I have this, now I have some points that I can use to actually draw the circle that goes around that circle. So as best as you can, you draw that circle out. Make sure that they're not straight lines. This is in the box. Now I have a little tool here. Let's see if this will help me a little bit with my circle. Yeah, this will work. And so just like that, with a little cheating, right? Because I use the circle tool. There's my circle. Look at that. It has a radius of 4 because it goes 4 in every direction, 4 spaces, and my center is negative 3, 2. So when they give you an equation, you have to pull the information out of it. You're going to try one on your own shortly. Then there's a very quick question. And again, this is all coming from your test. So that means you're going to have one this simple. It says the diameter is 15 feet. What you need to remember is for a lot of the things that we do with circles, diameter isn't something we want. That's why the question is asking, well, tell me what the radius is. Well, in our word wall, we've already written it in there, but when you have a diameter, if the diameter is equal to 15, then to find the radius, you have to take that 15 and divide it by 2. Now, of course, you can use a calculator, decimals, right? And then 15 divided by 2 is 7.5. And so if my diameter is 15, my radius is always half of that. It takes 2 radius to make 1 diameter. And just like that, there's my answer. Again, meant to be an easy little topic, but it's one thing that people tend to forget to do all the time. So let's keep this thing going. Let's flip it over here. We're going to try 2 more and then we'll pause the video. Now this one gets a little bit more interesting. In fact, I'm going to have to zoom out. So you see you have one there to try out on your own. All right, so here we go. It says reflect circle W prime across the y-axis to create W prime. Then you're going to translate circle W, which is xy, x minus 2, y minus 3, to form circle W prime, double prime. Use the graph below to show your work. Okay, so first things first. What I want to look at is I see the center, but I also need one more thing. Look at that, 1, 2. I need to know what the radius is so that when I draw my circle, I can do the same thing for it. All right, so the first thing they wanted me to do is reflect it across the y-axis. So here's the y-axis, here's the mirror, think of it that way. And what we've done in the past is, if I'm on this side of the y-axis, then I'm going this way. And according to what we did in the past, we go 1, 2, 3 to get to the mirror. So then I go 1, 2, 3 away from the mirror. So this is the new location of my W prime. And now I need to redraw the circle. So we already said, well, I have to go 3 up, 3 down, 3 to the right. I have to do 3s all the way around. So there's 3 right there. 1, 2, 3, 3 right there, 3 right there, 1, 2, 3, 3 spaces right there. All right, now I'm going to use my tool here to help me make some circles a little bit better. So do that, and close enough. There is my circle called W prime. Now they are asking me to do one more thing. So there's my first answer. And yes, this is what you're going to do on your test at some point. So there's my W prime, x minus 2, y minus 3. Now they want me to translate it, x minus 2, and then they said y minus 3. Okay, so they want me to do y minus 3. Keep in mind, look at where you're at right now. The center for W prime is the point 3, comma 5. And so when you do W double prime, look at what they said. They said for the x's and for the y's, it says, look at what they told us. For the x, they want us to take away 2. Take away a 2. So 3 take away 2. There's my new x value. For my y, it says y minus 3. Take away the 3 then. 5 take away 3 is 2. There's the new location for my circle that's going to be called W double prime. So I go to 1, 2. All right, it's going to get a little messy here. 1, 2. There it is. And once we do that, we're going to do this again. So it's going to get very messy here a little bit. We now need to count 3 spaces. Remember, that's our radius. I got to go 3 spaces. 1, 2, 3 down. 1, 2, 3 this way. 1, 2, 3 this way. And 1, 2, 3 this way. Remember, that's after the move that we had to make for this problem. So here we go. We're ready to draw this circle. It's our last one because this one is called W prime, double prime. And if they overlap, hey, that's okay. That happens. And so I draw my circle. And just like that, look, we're done. We needed 3 circles in this picture, the original, and then the other 2 provided for us. All right. All right, let's try one more. One more of these problems down here at the bottom. And then we'll pause the video so that you can try the first few out. Now, which point lies on the circle with this equation? Now, this one's a little bit different. They're asking which one of these points is on this circle. They're not asking for the center, that we don't need that. They just want to know which point is actually on the circle. So pretend that I were to draw this, right? So here's that circle. Pretend I drew it on a graph. Look at my center. My center, if I look at my number, look, opposite of -5 is 5. Opposite of -3 is +3. And then my radius would be a 4, and that's fine. I don't need that. What they're asking me is, are these points, and I got to check all of them, are they on the circle? They want to know that. Will it land? Now, there's 4 of them. They want to know, are they actually on the circle itself? So the only way to figure that out is we have an equation that I'm going to use. My equation says x minus 5, notice how I didn't write the x on purpose, plus, I don't want to write the y, so it says y minus 3 squared, you got to make sure you have that power of 2, is equal to 16. All I'm going to do is, I'm going to keep plugging in x's. I'm going to start with that one. And then I'm going to plug in a y right here. And I'm going to start with that one right there. And who's going to do all this work for me? Desmos is. Desmos can do every single one of these problems. And this is exactly what we type into Desmos. So on Desmos, I write this out. And then I'll plug in the -9 on Desmos. And then I'll plug in the 3 on Desmos. And then when I work this thing out on Desmos here, let me do a quick little calculation here on the side. We end up with an answer of 196 is equal to 16. Does 196 equal 16? Absolutely not. This is a false statement. And if something is a false statement, then no, that's not on the circle. But that doesn't mean I'm done. I'm going to do this again. I already checked this point, right? We already checked this one. So now I have to do it again. Remember to choose all that apply. I have to do it for all of them. But Desmos, the great thing about it, even though here I'm going to write it over and over and over and over, on Desmos, you don't have to do that. You're just going to change this number with the new ones. That's why don't delete the whole thing on Desmos so that you can do it a little bit faster. So that's where I'm going to put the 1. And of course, this is where I'm going to put this 3 right here. Remember, I'm testing a whole new set of numbers. So I'm putting a 1 here, and I'm putting a 3 here again. All right. So when I work this side, now remember, this is what I'm putting into Desmos, not the 16, just this right here. That's what I put into Desmos. When I put it on Desmos, my answer it gives me is 16, and it says equals 16. That is absolutely true. So is this point on the actual circle? Absolutely. And that's what we're looking for. We're looking for points that actually land on it. Well, then if it lands on it, Desmos will tell you that these numbers will be the same. Again, do not put the 16 in Desmos. You're only putting this side. You're the one that'll check if it equals 16. All right, but they said choose all that apply, so I do have to do this a couple more times. So look, I'm just going to get them ready. So that was this one right here. All right, next one. I'm just going to get this ready for both. Again, because I'm not putting Desmos on the screen, I'm just going to show you here how we very quickly, and look, I'm going to set up the other one. Same thing. Luckily on Desmos, all you keep doing is just changing that number in the front. All right, I'm going to start off with this one right here. And then this one will go right here. So we're going to plug it in, see what happens. This is a 5, this is a 1. And so when I throw, remember, just this on Desmos, just that part, don't leave out those powers of 2, the calculator, Desmos, is going to tell me that the answer is 4. And does 4 equal that 16? Again, absolutely not. We have yet another false statement. Then I got to cross that one out. But I still have that last one. I'm going to plug in the 5 right there again. I'm going to plug in this 7 right in that spot. It's just plugging in, and you're doing it on Desmos to save time. Here's the 5, here's the 7, and according to Desmos, all of this side right here is going to equal 16, and that's what we want. 16 is equal to 16. This thing works out perfectly, and so now we can easily say that, yes, this is a true statement, and so, yes, this is one of my answers, okay? All right. So right now, we're going to pause the video so that you can do basically everything up to number 10 over here. So we're going to give you some time to work on that, and then we'll come back and do the rest of this classwork. So let's stop the video now, and let's get to work, and you need to finish everything up to number 10. All right, now that you've had a chance to work on everything up to number 10, remember, you should be checking your answers with the key. The substitute teacher here has a key for you here. All right, so here are the last 4 problems. Yeah, last 4 problems. Now, this is a throwback question for us. And so, yes, your test is going to have some of these throwback questions for you. So here we go. Let me get my word wall here. I see that there's a 90-degree triangle with a 60 in it. So this goes back to our previous lesson. See, it has a 60 in it. Then I'm going to be applying this part of the word wall. And this part of the word wall is the one that we say small, medium, large. This is the smallest side. This is the medium. The hypotenuse is always the largest side. And then when we do this, there's the small, medium, large. Well, look what else it says to do. The small, it says call it K. The medium is K radical 3. And the large is 2K. Well, we got kind of lucky. If you notice, look at the side they did give us. They gave us the small side. So that means I get to put a 7. And now that I know that that's a 7, I can get rid of this. We don't need it. But now that I know that that's a 7, then that means K is 7. Hey, there's a K, so that's 7, radical 3. There's a K, so that's 2 times 7, not 27, which means the large side is 14. And then looking at it carefully, they said, well, tell me what B is. Well, B is the medium. So here we go. B is equal to the medium, which is 7 radical 3. And just like that, we're done with that problem. Now, if you're wondering, well, why did we have this throwback question? Well, if you notice, look at question number 12 right below now. Let's see if we can keep it both together. Yeah, we can keep them both together. All right. So here it looks a lot more complicated. It really isn't, but that's why we have to know our vocab. AB is tangent to circle C. There it is. Look, it's outside the circle. It touches once. That's one of our new vocab words when it comes to a tangent. See, right here. A tangent touches a circle once and is completely outside. So there's my tangent, AB. And CB is the radius of C. So they said CB is the radius. Yeah, we know that already. The radius of circle C is 5. Well, I don't hesitate. If the radius is 5, then I put a 5 right here in my picture. Find the length of, and they want me to find the distance from C to A. And if they want me to find C to A, they want all of this. All right, but here we go. Look at this thing. When I look at this picture, yes, there's a 90. Yes, there's a 30. That's exactly what we did up here. This is a 30, 60, 90. This is a 30, 60, 90 triangle. So I have to do the same thing I did on this problem to this problem. Even though there's a circle involved, that doesn't really matter. What I'm really looking at is, I'm just looking at the triangle. The circle really doesn't matter here. So here we go, look. Small, medium, large. Small, medium, large. We already know what to call them. They said call it K, K radical 3, 2K. And so now that I have that, well, look at what they gave us. Again, we got lucky. They gave me the small side. The small side is 5. So I put a 5 right here for small. Now I know what K is. So if I see a K, I'm putting a 5. But it needs a radical 3 here. I see a K there. Then I go 2 times the 5 again, which means this is 10. And now think about which side they wanted. They wanted to know what's the distance from C to A. Well, that's the large. Then C to A, the answer would be 10. That's what C to A is right there. But again, it's this little formula where the word wall comes in handy. But this was a throwback question mixed in with a circle concept, but it still applies. All right, 2 more to go. Now, AB is the diameter of circle A. All right, we've talked about this. They said this is a diameter. And if that's a diameter, then you need to remember one key feature of that. If this is a diameter, then it means that this part of the circle right here, because there's no breaks in it, automatically measures 180 degrees. Because a diameter cuts a circle right in half. Now, what some people are not realizing is that means this whole side is also 180. So I could bring up 180 over here, but because there's a letter, I don't want to write it in yet. I still have to see what else they mention. But they do say angle AOC. Well, trace it. AOC is 74. Remember, every angle in a circle is connected to an arc, which means this is the arc that belongs to that angle. But you have to watch out. Too many of you think, oh, I got to multiply by 2. No, no, no. There are two different things here. We have an inscribed angle, which touches the circle 3 times. That's when you multiply by 2 or divide by 2. But then you also have what we call a central angle. The angle actually comes off of the center. Well, look at this one. This angle that I traced is coming off of the center only, which means they're equal to each other. You don't have to divide, you don't have to multiply. If that's 74, then this is 74. And now let's read the question. Here's what they want from us. Find the measure starting at B, ended at the C. So they want me to start here. They want me to finish here. But because there's 3 letters, they want me to go the long way around. They want all of that pink stuff right there. So if that's the case, it's very easy to see that all I have to do is take the 180 that I just passed right here, and I have to add the 74, that's the green one. Oops, 74, there we go. And so we add it up together, right? And we get 254, and that's the answer for BAC, 254 degrees. But that's why you can't mix up those two rules. If it hits the center, they're equal. If it hits the circle 3 times, that's when the multiplication or division by 2 happens. Which brings us to the last problem of the day. Like we said, it was going to be a quick little lesson here, or review, really. Remember, all of these are on the test. That's why you need to make sure you're attacking these on your own and trying them out on your own to test your skills. So it says, quadrilateral ABCD is inscribed in the circle. Now notice, this is a 4-sided figure, and yes, 1, 2, 3, 4. It touches the circle 4 times, which means here comes one of our newest rules of the week. If it touches the circle 4 times, then the opposites, look at that, look at those colors there, the opposite angles are supplementary. So all I have to do is add them up and make it equal to 180. But again, it has to do with opposite angles. So they want me to find what C and D are. Well, let me do one at a time. Let me talk about, they said angle C first. All right, so let's talk about angle C. This is angle C. But the opposite of angle C is not this one. The opposite is over here. They're the ones that are opposites of each other. And according to this rule, because it touches the circle 4 times, then C plus the 98 should equal 180. Well, all I have to do is now a quick little subtraction. Subtract the 98. This is not a 360 question. So 180, take away the 98, and then we get an answer of 82. Well, just like that, we found this answer, 82 degrees. And then they said, well, find me angle D. Well, angle D is over here, this green one, and the one that's opposite of angle D is this one that measures 104. Well, the rule is, if they're opposites and they're touching the circle 4 times, right, then D plus the 104 should make 180. So once again, I'm just going to do a little subtraction. And with that said, D is equal to 76 degrees. And there's my answer. You basically just saw, let's see, this would be 9 of the questions that you're going to see on the test. So again, get the practice in. You now need to finish everything up to number 18 that you see here on this page. And then you turn that in. And then you're going to have a homework assignment. Well, guess what? You're going to practice the same exact problems. So in all honesty, I would do the classwork and the homework both together so that you have all these notes with you, right? And then once you have both of these things done, then you should just turn it all in at the same time. Just make sure everything has your name on it. All right, everybody, make sure that anything else that you owe me, some BIMs, some old BIMs that are out there, the handouts, the worksheets, You're going to have plenty of time to get everything done today. Use the time wisely and make sure you're caught up with everything. With that said, have a wonderful day, and I'll see you next time.